Hi everyone and welcome to the new video. Today I want to show an interesting device that I bought on eBay. It is a portable focusing prism spectroscope for gemstone analysis. And the funny thing is that I am not a gemologist, so I will review this device from the physics perspective and I will show what fun things we can watch with that. So without further ado, let's get started. First, for those people who somehow missed all physics lessons in the high school, I will shortly explain what the spectrum is. All visible light we can see is actually a mixture of different wavelengths, and even if we can see the light as white, with a prism we can split it to different waves, and it was made first by Isaac Newton and known from the 17th or 18th century. And the cool thing is that different types of materials absorb or emit light differently, so by analyzing the spectrum you can know more about the matter. For example, if it is a gas lamp you can figure out what kind of gas is inside. Or in the case of gemology, you can know if it's real or it is a fake stone. So let's see how the real spectra looks like. Let's get started. First, before we begin, let's understand the simple but important difference. A spectroscope is a device that allows you to watch the spectrum. You can actually watch inside with the naked eye, and you will see the spectrum, but technically you cannot record it. Of course, you can use a smartphone, but the quality will be not so good. And the spectrometer is another type of device. It usually has a USB port, so you can export the data to a computer, you can see it on a big screen. It is more expensive and it is often not portable, but it is much more functional. So the choice depends on what do you need. And I will also make a review of the spectrometer later, so stay tuned and subscribe if you want to see it. And now let's do a little unboxing. The unboxing is actually pretty short because there is not so much to show. This device is portable, it has only this cover and that's actually it. Inside the device there is a prism and there is a focusing knob, so you can move it and you can adjust the focus. So you just point the spectroscope to the object you want to see, you adjust the focus and you can see the spectrum. You can do it indoors or outdoors. Originally this spectroscope was made for gemstones, but you can also use it, for example, to watch the spectrum of the street light, it works well. And now let's get started and let's see some spectra. Okay, let's do some tests. And the first and the most classical one is the spectrum of the compact fluorescent lamp. This technology is surprisingly old, and the first fluorescent lamps appeared in the pre-World War II era in the 1940s. Compact fluorescent lamps appeared later, they were invented in the 70s and they became popular as the energy-saving lamps. These lamps replaced incandescent lamps before LEDs. Technically, the fluorescent lamp has a gas inside and the phosphor coating. The gas is glowing in the ultraviolet and the phosphor coating is glowing in the visible light. And what is interesting for us that this phosphor coating has a very specific spectrum, it's linear. Let's turn this lamp on and see how it looks. I bought this lamp in a second-hand store for only 50 cents, so I don't expect too much. And when I rotate this lamp, I hear the weird sound. But surprisingly it still works. I don't have a special fixture for it and it is pretty long, it does not fit my table lamp, so I will connect it directly. Please don't do it like this. And as we can see, it is pretty bright. Here we can see a classical fluorescent light spectrum, and here we can see the wavelength from 400 to 700 nanometers, as we can see on the screen. In the reality the image looks better than here on the camera. It's more clean and more sharp. And interestingly, this phosphor contains some rare earth elements and there are lots of things going on there. And it is also interesting that for our eyes this light looks white, but technically, as we can see, it's only lines of the spectrum. It's much more monochromatic compared to, for example, sunlight. As the second example, I can point the spectroscope to the sun and we can see a completely different picture. We can see mostly full spectrum, but there are also vertical lines here. These lines are called Fraunhofer lines. And interestingly, these black lines are formed in the solar atmosphere when the atoms absorb the light. A German physicist, Joseph von Fraunhofer, observed these lines in 1814, so it is a pretty old discovery. It is also interesting that when we watch the rainbow we think that it's perfect, and most of people don't know that there are black lines on it. Funny enough, when I first pointed the spectroscope to the sun, I saw these black lines and I thought that the spectroscope is broken, that something wrong with the prism. I did not know that these lines are here. So even with this small device you can learn something new. And now let's go forward and let's see the spectrum of the vintage neon light bulb. Neon light bulbs are still popular today and they are used a lot in the devices like power sockets, we can see them often, but this one is completely different and as we can see it is much bigger. It also has a standard E27 socket, so it can be used in a standard fixture. Technically this is still a neon bulb, it has a neon gas inside and the current limiting resistor. And as a comparison here is the small one, we can easily see the difference in size. And now let's turn it on. And as we can see, it is a very interesting glow. It's maybe not really visible in the camera, but it is beautiful. And now let's see the spectrum. In the real spectroscope it looks much better than in the camera. The image is much more colorful and it's much sharper. But even with this quality we can see that the neon light mostly consists from red and yellow lines. And I can also see a green line that is not visible here. As a reference I can show a Google image that looks much better. And now let's go forward and check some street lights. As for the street lights, there is obviously no universal standard. The results may depend on the country and municipality. I live in Amsterdam, so I will show how it works here. Let's get into it. I took a spectrometer with me and it turned out that about 99% of the lamps use LED lights. The spectrum of the LED light looks like this, and as we can see there is a drastic difference compared to the fluorescent light. The spectrum of the white LED is more continuous, and on the fluorescent light we can see these vertical stripes. And as I mentioned before, at least in Amsterdam, 99% of the lamps are already converted to LEDs. Why 99%? Honestly I don't know, but it was interesting to see that some lamps are still old. This is a good example. I took this photo in the evening. And as we can see, all lamps are using LEDs, but only one lamp is different. And with the spectroscope I can easily see that it is still fluorescent. Why? Honestly I don't know. Maybe the municipality just waiting until these old lamps will reach their end of life. So maybe this is the last one on this street. Here is another good example. This is a lamp post and here we can see two lamps of different types. And one lamp is an LED and the second one is fluorescent. And interestingly, I took the photo at the daytime and there is visually no difference because the lamp is inside. So we can see the difference only when the lamp is turned on. Anyway, in general most of city lights in Amsterdam are already converted to LEDs, but I was able to find an exception. When I went to the highway, it turned out that all high power lamps are still fluorescent and there are no LED lamps here. Why? Again, I don't know the answer. If you know, please write in the comments below. Maybe if we need a high power, fluorescent lamps are still more efficient. And how it is going in your place? I will be curious to know the answer. And now as a next step I will return back home and I will show the spectra of some fluorescent minerals. As a reminder, this spectroscope was originally designed to check gemstones. I don't have any gemstones in my collection, but let's check some minerals. The first one is pyrite or iron sulfide, also known as fool's gold. Technically it does not glow, it's only reflective, so there is no reason to check it with a spectroscope, but it just looks cool, isn't it? It's just interesting to see how this perfect shape can be formed in the nature. But let's go forward. The second mineral is called hyolite. I am not sure if I pronounced it correctly. This mineral is from Namibia and it really nicely glows in the UV light. It's really bright like an LED, so I can put it under my UV torch and I can watch it with a spectroscope. In the UV light this mineral is really bright, and by the way, this white spot in the center is a camera artifact. In the reality it's not white, it's just a bright green. It's just the dynamic range of the camera is not enough. And it is interesting to see the results. There are two distinct green lines, and also we can see some red lines here and a bit of blue. And interestingly, this green spectrum is not continuous, we can see two distinct lines, but of course they are not visible with the naked eye, so that's why it's nice to have a spectroscope. And now let's go forward and check the next mineral. This mineral is called willemite, and as we can see it is completely different. This is a silicate mineral, you can see formula on the screen. It is also glows green, but interestingly the spectrum is different. In the previous mineral I saw two distinct lines, and here there is only one line. I don't know why. If anyone knows, please write in the comments below. Alas, this mineral is not really bright, maybe because it's not transparent and only the top layer is glowing. Okay, it was the last test for the video. Let's make a short summary. Does it make sense to buy this portable spectroscope if you are not a gemologist? And as we can see, it is an interesting device and it was fun to test it. I enjoyed it. Of course, it is not a spectrometer. You cannot get the analytical data from it. You cannot get the exact wavelengths. And it's not so easy to connect it to the computer. As we saw in the video, you can make some pictures, but they are not very accurate and it's hard to do it. Maybe you need to 3D print a case for that. But this device is a good complementary tool for the USB spectrometer. The spectrometer is small and portable, it easily fits in the pocket, and the picture is bright and sharp. I enjoyed it. And it is also convenient outdoors. For example, if you want to test a street lamp, carrying a USB spectrometer and the laptop would be definitely not so nice. So a portable spectrometer is not a replacement for the analytical tool, but it is a good addition to it. And that is it for this video. Thanks for watching. I hope you learned something new. Press like and subscribe if you enjoyed this content. Also feel free to visit my Patreon page. Your support may help me to buy stuff like this for testing. I will make more videos about spectroscopy, so feel free to subscribe. Thanks for watching and see you next time.